Hi, everybody. Thanks for waking up this morning. It's sort of being second session here. I'm Podjarny, or Gaipo at Snyk, and I'm here today to talk about security, to talk about writing secure node code. Just for context, a little bit of history about me is I am at Gaipo at Twitter. Right now I work on Snyk that deals with open source security, and I have a lot of experience in the web security space, application security, and the web performance space prior to that. And I talk a lot on conference circles, Twitter, blogging, etc. So JavaScript is awesome, right? I think everybody sort of here would probably concur. You're sort of coming to this office, this conference, and we like to talk about how JavaScript has won, and it's kind of the dominant language in many metrics. And there's a lot of reasons for it, and there are a bunch of these notable JavaScript traits that we can point out that make it great, like some built-in memory management, so we don't need to worry about that as compared to maybe some other languages. It has some built-in native serialization, like JSON. It's naturally scalable, and a variety of other properties that make it powerful, that make us productive, and we'll build in it. And these are great, and they make us productive, but sometimes the very things that make JavaScript awesome, make Node awesome, also make it vulnerable. So you might look at that list and talk about the productivity, but I look at that list and I might see some flaws. I might see some potential security risks. If you have built-in memory management, but is that comprehensive? Is there places where you might leak some information out? Can I manipulate types in this dynamic typing environments and trigger some vulnerabilities? There's a bunch of these types of flaws, and it's important as we build applications in JavaScript to be aware of those and to try and avoid them to the extent we can. So a lot of this talk is going to be around those components, but another important piece of context is that these types of capabilities as well as flaws are not just in your own code. When we develop in Node, we also use NPM. And NPM is also awesome, and it also makes us productive and lets us run faster. And as a result, NPM usage has exploded, right? Like this, the numbers on the slides just keep getting more and more ridiculous every time I need to update it, just in terms of sheer volume. And it leads to the situation where this is your app, and this is your code. I like to kind of point out that this might seem like a negative slide, but it's actually a positive slide, because all you had to do is write that little purple dot to get all of that orange-ish value. And it's a good thing, but it's also a scary thing. It also implies some diminished control. So most of your application's code comes from NPM, which also means most of your application's vulnerabilities come from NPM, from all of this code that you're pulling in that runs in your system. It's just important to understand. This is not a theoretical problem. We see that about 1 in 7 packages in NPM carries a known vulnerability, either in its own code or in one of the dependencies that that package in turn uses. So it's a very real problem, and most of your applications probably have use of some of these vulnerable components. And this applies to Node applications, which is where I'll focus today, but it also applies to front-end applications as more and more third-party code makes its way into that space as well. So what we're going to do in this talk, just with this context, is actually leave Keynote here, leave the presentation, and we'll do some live hacking, which is always fun. And what we'll do is we will use real vulnerabilities in real NPM packages and understand them, exploit them a little bit to understand their impact, and then use those both on one hand as awareness to the potential risks that might come in that NPM package, as well as a learning vehicle to understand how should we write secure code ourselves. And then we will focus on Node, but again, this sort of applies to client side too. So with that, let me move over here. I'll switch to the browser. Everything loaded well. OK, so this is a JavaScript talk, so of course I have to-do MVC application in it. This is called Goof, and it's a vulnerable to-do application. It is vulnerable by virtue of pulling in some of these vulnerable packages, and it allows us to do, it's a to-do application, right? So you can call it buy milk, or you can say call mom, or all sorts of reminders for you to do. And Goof is an open source application. It's on Snyk/Goof, and you can try it. So what we're going to do is we're going to test it and see which vulnerable packages does it use, and then we'll see what is the implication of it. So I'm going to use Snyk for this. We'll go off, choose the relevant application. So over here, Snyk would have tested the different packages that I have, or different repos for vulnerable packages, and I will choose Goof and see that I have a bunch of these vulnerable packages on it, right? So this is sort of step one, just to understand that you have those vulnerable components in your system. And there's a bunch of them here, and I'm going to pick a few that I have sort of easy exploits to show, but there's a bunch of these vulnerabilities that you can read up on, including a fairly recent one that was just published on EJS, remote code execution in the enterprise, in the EJS templating platform. So we're going to start with a simple exploit here on ST. So ST has a directory traversal vulnerability. And typically, you would read the advisory on this, but you don't need that because you have me, so I can show it instead. So we use ST in our application to serve static resources, public, like CSS and style and JavaScript files, as well as to show kind of our awesome about page, which is just sort of demonstrates how awesome Goof is. So to exploit it, we're going to switch to the command line because the browser is just not sufficiently friendly for hacking activity to go. And I'm just going to have some shortcuts for me. We're just going to go off and we'll do a bit of a curl. So we'll switch to sort of warm up and get our about page via curl. So far, so good. Now we know there's a directory traversal vulnerability. So when you have that, what an attacker would try to do is break out of the folder where the static resources are and try to get outside. So it's going to try to do something like this. And if you do that, you will get nothing, actually. You'll see that you got redirected to the Goof to do homepage. And the reason for that is that ST is a good package. It was written by Isaac from NPM, and it has some security consciousness in it. And it did try to avoid this specific concern. However, it has a vulnerability, and that vulnerability is in not factoring in all the different encoding paths that you could have. So what's another way I can represent a dot in a URL? Anybody? Oh, sorry, didn't catch the whole thing. I will assume that you said URL encoding, although I'm not sure if that's the one, which is I can do a %2e. And if I do %2e, 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 and I can just go back as much as I want, because I can just do dot dot at the root folder as much as I want, and then say I tacked on etc pass wd, and voila, I've got the etc pass wd file. So we're just getting warmed up. This is a very simple vulnerability, but it just sort of shows it's a good package. It has security consciousness, but it has a flaw, which was fixed at a later version of this package. So getting started, first package, first lesson is just beware encoding. The second package we're going to look at is marked. Who here has heard of marked? OK, a good number of hands. It's a markdown parsing library, and we use it in Goof to be able to do things like emphasis, like if I want to say by beer, and I want to give it the sort of the proper attention that it deserves, then I can use it for emphasis as a variety of other components in it. Goof uses marked, and marked is, it gets about 2 million downloads a month, and it has a vulnerability that is a cross-site scripting vulnerability in how it processes it. So let's kind of go through a little bit and understand it. Again, typically you would read the advisory. So if I know there's a cross-site scripting vulnerability here, what's the first thing I will try? Script alert 1 / script, and I don't get anything. I just get it to text. Once again, marked has a security controller in it. Unfortunately, it's not on by default, called sanitize. But if you turn on sanitize like we did here, it would capture this. And it's really comprehensive. Even if I went ahead and I did something like this and said JavaScript : alert 1, which is another way to sort of embed a link, it would still catch it. So sanitize is a pretty good function. But again, there's a vulnerability in here. And that's because, once again, encoding was overlooked. So how can I encode something in the HTML? No? Not as well known as a URL encoding is HTML encoding, HTML entities. So I can do something like this, and I can do %41, I think. And these are basically just equivalent ways to represent a character, ASCII or otherwise. And the browser would interpret them the same way it would regular code. So if I do this, sanitize still catches it. So it really is a very comprehensive and sort of spec-compliant type of defense mechanism there, sanitization function in marked. So marked was actually fine. However, browsers, not so much. So browsers, say I do something like this and I add like this over here. Browsers go here and say, well, I see the ampersand, I see the hash mark, I see the 58. You didn't go all the way and kind of add that semicolon there, but I know what you want. I've got your back. That's OK. This is a colon. So if I do this, voila, suddenly I do manage to get through it. So marked was actually good. They sort of did the right thing, and they are very spec compliant. But the browsers, with their flexibility and just like this complex world of evaluating pages, did allow that to do it, and we got sort of a script into it. So again, both examples are all about encoding and be able to sort of circumvent existing sanitization logic is a very, very common problem in NPM packages and in Node code as a whole, and it's something to be kind of aware of. So these were 2 packages. Let's look at a couple more, and then we'll kind of conclude a little bit more. And we're going to get fancier as we go, kind of get a little bit more complex. The next one I want to look at is MS. Who here has heard of MS? Okay, a little bit less. It's actually also very popular, and we use it. It is a package that converts all sorts of date strings to the number of milliseconds. So we can say, call mom in 2 days, and it would figure out that the 2 days means so many milliseconds, so we can set a reminder for it. So it's a nice little package, very widely used, and it is susceptible to a regular expression denial of service vulnerability. So here it's probably worth stepping back a moment and talking about the event loop. So one of JavaScript's claim to fame is the fact that it runs on the event loop, and it's therefore naturally scalable. If you want to serve many clients, you don't need a thread per client. You launch one thread, and all of the blocking actions, all of the I/O functions are event-driven. So therefore, that single thread, can process many, many different clients. And that's true, and it's a good thing, but it means that if our code misbehaved, if we ran an infinite loop, or if we ran a very slow-running algorithm, it would take up that thread, and it would now deny service to all of these different clients at once. So it's just a tiny bit more fragile. And while we don't think of them as algorithms, the most popular algorithms, or most frequent algorithm that we run in our code is a regular expression. And actually, let me go back a little bit to my slides just to sort of explain this in an example. So regular expressions are algorithms, and they're really a state machine. They run through a string, and they typically take a non-linear amount of time to process input, non-linear to the length of the input that they got. So let's look at this fairly simple-looking type of regular expression. It just says, A, B, C, D, E, and C can be multiple times because of the C+, or it can be multiple times because of the brackets. And what that means is that when we give the regular expression engine something that is almost there, that almost matches, regular expressions are greedy. They aim to please, right? And they would run through it, and they would get all the way to the end just to realize that they could not match, and then they would backtrack and try another permutations and then backtrack. And if you did this model, you would trigger what's called as catastrophic backtracking. In this case, the problem is that this C letter can show up either as, like, multiple occurrences can show up as the plus, or they can show up in the capture group there. And that leads to many, many, many different permutations. And it means that even a short string like this is 30-ish strings, may take a second to process, and every character you would add might double that amount of time. Now, clearly, this is on a computer, but it would take down threads very easily. So this is an extreme example of regular expression denial of service. And basically, this happened on Moment, which is another popular package, which we use in Marked, but I don't have a handy exploit to it. And you could take down a server with even 30 or 40 characters. In the case of MS, it required a slightly longer exploit. And if we're going to do this, what we would do is we would switch to the command line again, and we would just run this little action here. So we're going to print 60,000 fives as the duration of time, and that would again sort of trigger a long string that goes into that regular expression. And the other thing we're going to do is we're going to change the S here to an A. So it almost matches. It gets all the way to the end, but doesn't quite. And if we do this, it takes a long time to respond. And in the meantime, what's maybe more interesting is if we go to the application and we try to do things here, nothing happens. It's stuck. And it's because the thread is now occupied processing this long regular expression. Now you might think, hey, 60,000 characters is an abnormal length of input, and you'd be right, except somebody needs to actually ask that question and block the long input coming in. And in most cases, that doesn't exist unless you explicitly put that in there. So hopefully, if I added a 0, then this would have taken basically the entire length of the presentation. Hopefully, this is now done. And the system can run again. The fourth vulnerability, and the last one I want to show, is in Mongoose. Who here has heard of Mongoose? Yeah, probably everybody. So Mongoose, clearly the way to interact with MongoDB. And Mongoose has a slightly more elaborate vulnerability triggered by buffer. Buffer is a tricky object in the world of Node that you might have heard of. And the reason it's tricky is that it deals with memory. So if I just sort of run Node here, I'll zoom in even more. Buffer supports two constructors. So I can do a constructor that says buffer, new buffer 100 with a string, and it would give me 3 characters, 1, 0, 0. Or I can do new buffer with 100 like this, and it would allocate 100 bytes. And that's fine. It's a little bit weird that you can pre-allocate things in JavaScript, so it's a bit of a unique entity in the sort of JavaScript world. But what's more interesting is that if you look at this, you see that every time I allocate the memory, I get a different type of content. And that's because buffer does not, by default, zero the memory that it allocates. It just takes up whatever chunk of memory and just uses up those 100 bytes. So if now as an attacker, if I can leak that information out, that allocation out, and get that to me as an attacker, I have remote memory exposure. I suddenly can access server-side memory, and if I do that enough, I will basically expose pretty much all the secrets that sit in the node process's memory, including source code and keys and the likes. This is what happened with Heartbleed in OpenSSL. This is remote memory exposure. So because buffer is so tricky, because the constructor is like this, it tripped up quite a few packages, Mongoose being one of them. Now we use buffer as a part of our database schema here to hold our content entities. So what we need to do is we need to somehow trigger the allocation of the use of the integer buffer, and we're going to do that using a technique called type manipulation. So if I go here and I do this, what we'll do is we will switch from using a curl form posting to another type of input that our application supports, which is JSON. Very popular, very prevalent, again, in the world of Node, right? One of our advantages, we can take JSON as input. But what we might have forgotten is that in JSON, while I can do something like this, and I can say, whoops, I can say content 800 like this, and I will get, if I go back to my application here, and I reload, I will get a string 800. With the JSON serialization, I can also do this. And what this would do is when I serialize, or when this object gets created in JavaScript, this would now have a type integer. And again, unless anybody verified it in the process, that type integer would now be passed into that buffer, would be stored into that database, and now that record holds some real-world memory. And I'm just going to get some binary craft here. And if I did this again, I'm just going to get a bunch of those, and sometimes you might start seeing some source code in it, but it will be a different chunk of memory every time. So this is remote memory exposure, not good, very problematic. Again, a bunch of popular packages have fell for it, including Request and I think WS, so something to be wary of. So these were just a few examples of vulnerabilities. What I want to do is just spend the last couple of minutes talking about remediation, right? Hopefully there are some examples here about things that you should do, in general, a reminder that you should care about security when you write Node code, and some specific examples of things you can take care of. The other aspect is that all of these vulnerabilities were in NPM packages. Goof actually has a couple of vulnerabilities in its own code, but most of the vulnerabilities in it are from NPM packages it consumes. So talking a little bit about that, the way that you would address that is first test for it. So you can use Snyk, you can use whatever tool that you want to try and know that you're using a vulnerable package. And second is you want to fix it. The way that we do it in Snyk is you just click here to do an open fix PR, which would prompt you which fixes do you want to do, and then click this, and it will generate a pull request with the necessary changes. We have patches for some of these vulnerabilities, and we have guided upgrades to various others. So this is really with the intent that you can kind of build this in to your workflow and make it a natural part of your GitHub workflow or CLI workflow or whatever workflow that you have on an ongoing basis. And then you want to make sure that you do this continuously and that you, once you are vulnerability free, that you stay that way, right? That you don't just, you want to first identify the problems that you have today and fix them, and then subsequently you want to do that in a continuous fashion. And the last thing you want is you want to be set up to be able to get alerts or be reminded about new vulnerabilities, because once a vulnerability in code gets disclosed, it is now known to the attackers as well, and it is that much more likely to be exploited. So there's a bit of a race. Once a disclosure occurs, then there's this race that kicks in to say, who do the defender fix first? Does the defender fix first, or does the attacker exploit first? So you can stay on top of these vulnerabilities. Again, using Snyk, it'll be on your specific application, or you can check out our database on snyk.io/vuln and follow the components there. So to recap, back to my slides. First of all, don't go start hacking websites. It's not going to end well. If you really, really want to, you can go to github/snyk/goof and download this vulnerable application and just sort of have at it. That is on your machine and you're fine with it. Hopefully, this talk is giving you some takeaways around secure coding. So, just to recap what we've seen is encoding is tricky. Think about all the different encoding paths that you do when you have to build it. Be careful of long algorithm runs, and specifically for regular expressions, try to contain the input length and think about what you allow in. And just when you're building a regular expression, see, can you make it limited in length? Beware type manipulation. Type manipulation can actually happen through the QS package, through various other aspects. It's a little bit more unique to scripting languages. It's not as well understood, but it is a very dangerous type of attack. And beware buffer. Buffer does have in the newer nodes, there is a buffer.allocsafe and buffer.allocansafe option, that you should use those instead of the default constructor. And in the different packages, unfortunately, you have existing code that uses those default constructors. You could choose to zero the buffers as a command line with the risk of breaking some functionality but increasing security. I'll kind of leave that decision to you. About using NPM packages, I would encourage you to find those vulnerabilities, be aware, right? Get the head out of the sand, accept this is part of building a secure, a quality application, and find those vulnerabilities, fix them, prevent adding new vulnerable packages once you've done that, and then respond to vulnerabilities, new vulnerabilities quickly. A lot of different ways to do it. I'm biased, I'd say use Snyk for it, but just make sure that it's a part of your workflow. That's it. JS and NPM are awesome, but please enjoy them responsibly. Thank you. And I'll take some questions here, and I'll also say that because we like to say that Snyk fixes vulnerabilities like magic, we actually have magic wands that you could catch in it. So if you want one of those, just catch me after the talk. I'll give you one. Any questions? I think we can do a couple of minutes. Sure. Do you want to actually step up over here and just speak?
Do you guys do any auditing of private packages within organizations to discover vulnerabilities?
So we ourselves, Snyk, we don't do, we're not a services company, we don't do auditing. We do sort of recommend that you get a security consultant to do that for your code. So, happy to chat afterwards about specific entities you're talking to. I do think it's very important to secure your own code. That said, I think dynamics are changing, and today the majority of code that you deploy is third-party code, and that's also the easier code for attackers to exploit because they have access to it. It's just dramatically easier, and that's why today anywhere between 80 and 95% of successful exploits happen through unpatched known components, like unpatched vulnerabilities. And it's because it's the low-hanging fruit. So hopefully you do that. Other questions? Cool. Well, I'll let you get back to the break. I'm going to be here if anybody has any questions they want to step up. Thank you.